Hey AP Statistics, picking up with section 8.1. So last section we got the big idea of how a confidence interval works and how we get that point estimate plus or minus the margin of error. So in this one we're going to start out with, what affects the margin of error, and you could probably guess a few things. So in general, we prefer to estimate with a small margin of error. The margin of error gets smaller when we decrease our confidence level. So this is one thing we could do. We could be less confident, and so that would give us a smaller range. This is not necessarily ideal, but you can see the range of 80% confidence. For less confident, we can give a smaller range. Or the better way is if we increase the sample size. The increasing of the sample size reduces the margin of error for any confidence level, because when we increase that sample size, we expect less variability. So to cover whatever 95% of our sampling variability, we don't have to go as far. The margin of error also depends on the standard deviation of this probably should say the population. I guess the standard deviation of the sampling distribution of that statistic. So if in means, it's the standard deviation of the population affects it. In proportions, it's P. But that won't always be something we can control. So as we learned in Chapter 7, the sampling distribution of a statistic will have a smaller standard deviation when the sample size is larger. That's why the margin of error decreases as you increase the sample size. If we could somehow, which shouldn't happen, but if you could change sigma, the standard deviation of the population, and shrink it, that would help. If you could get P closer to 1 or 0, right, that technically would help, though that's not a realistic thing that you should be able to control those parameters. And you wouldn't be estimating them if you had control over parameters. That would be a very weird situation. So the margin of error does not account for any source of bias in the data collection process. That margin of error only accounts for sampling variability. Not if you're biased, then the margin of error doesn't take that into account. So for a normal sampling distribution, extend about 2 standard deviations in each direction from the statistic produces an approximate 95% confidence interval. So remember the 68, 95, 99.7 rule. So on a very simple level, it's not exactly right, but about 2 standard deviation covers 95% of the variability. For a normal sampling distribution, extend about 3 standard deviation in each direction to produce a 99% confidence, 99.7. So we'll start pretty simple there, but of course we'll want to be able to do more precise than that exact 2 standard deviations, and we want to do things in between. Like, what if I want to do 99%? Where does that fall? It's not 2 standard deviations, it's not 3, it's somewhere between 2 and 3. But we'll get there. The more general formula for a confidence interval is we go statistic plus or minus critical value times standard deviation of statistic. So here we're going standard deviations above and below. That's what the critical value is. The critical value is the multiplier that makes the interval wide enough to go to have the stated capture rate. So in the first example, that's critical value would be 2, and that one it would be 3. But maybe my critical value ends up being 2 point something, right? I need to go 2 points, so many standard deviations of the statistic away from that statistic to have that that appropriate capture rate. So example problem, as part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said she was 90% confident that the interval from 3.14 to 3.52 captures the mean GPA for all students at her school. So part A, explain what would happen to the length of the interval if the confidence level were increased to 99%. So if we're going to increase to 99%, that means we're going to cover 99% of sampling variability instead of just 90%. So if we're going to cover 99% of the variability, 99% of the sampling distribution kind of, we're going to have to get wider. And so the confidence interval would be wider because increasing the confidence level increases the margin of error. Part B, how would a 90% confidence interval based on the sample of size 200 compare to the original 90% confidence interval? So originally we had 25 students, now we're increasing it to 200 students. So that is a bigger sample, which we expect less sampling variability, so we expect a smaller spread, so we don't need to go as far. We are going to have a narrower confidence interval. Technically, we could actually figure this one out exactly This one is this margin of error and the standard deviation. If we go from 25 to 200, we're doing 8 times as much, and so it's going to be 1 over square root of 8 times the standard deviation, which is going to have that direct impact on the margin of error. So it's going to shrink by that much. Specifically, you didn't have to answer this question that specifically, though. You just had to be able to say the margin of error. Whoop, let me skip one. Oh, there it is. The confidence interval would be narrower because of increasing the sample size decreases the margin of error. And then the last one, describing one potential source of bias in Ellery's study that is not accounted for by the margin of error. So in this case, the margin of error doesn't account for the fact that many students might lie about their GPAs if you ask them, right? This is based on responses. Would have been better to look the data up without them. So people might lie about their GPA, and that would not cover be covered in the margin of error, right? We could be way off. We have no idea, right? That margin of error only covers our typical sampling variability.